All right, so for this opening exercise, again, hopefully you did find this to be relatively easy, or after you did the first one and kind of understood what you were doing. Name it whatever you want. I'm just going to call it A because it's letter A. If you want to call it V, that's fine by me. If they're all starting from the origin, how would you translate 3 units to the right and 4 units down? 3, -4. That word down would mean you need to go down. So if I graph that, that would be 3, -4. Remember a vector, like a portion of a ray. Remember, vectors give you direction and magnitude. So with that, it does want us to answer the magnitude. How do I find magnitude? Good. The square root of a squared plus b squared. So in this case, this would be 3 squared plus -4 squared. 3 squared is 9. -4 squared is 9 plus 16, 25. Square root of 25. There you go. Questions on how to produce a vector, how to graph a vector, or how to find the magnitude of a vector. All right, let's quickly do these three then. If I, no, I'm going to call this vector B. So this is A. How would I go from the origin 6 units left? Zero. Perfect. I did not go up or down. So this would be -6 to go to the left and then 0 to indicate I did not go up or down. So again, that would be about right here. And this would be B. So to find the magnitude of this guy, it would be -6 squared plus 0 squared. What's -6 squared? 36. 36 plus 0, 36. And then square root of 36 is 6. Good. Questions? Awesome. Vector C here, translate 2 left, 2 up. -2, 2. All right. So here we go. Here's my vector C. So to find the magnitude of C, I would do the square root of -2 squared plus 2 squared. What's -2 squared? What's 2 squared? Good. I think I noted yesterday, make sure when you are squaring numbers, it's always coming out as a positive. We do not square a number and ever get a negative. So what's 4 plus 4? 8. Square root of 8. I'm good with you leaving it there, but on an ACT test or something, they might rationalize this as 2 and 4 and then 2 and 2. Gave you 2 square roots of 2. We've done this many times. But again, on a test or something, I'd probably be just happy right there as well. All right. Part D. So vector D. 5 units right, 7 units up. 5, 7. 5 units right, because that's positive. 7 units up, because again, that's positive. So here we go. Here is D. So again, to find the magnitude of D, this will be 5 squared plus 7 squared. What's 5 squared? 7 squared. 25 plus 49. 74. And again, I'd probably just leave it like that. Any questions on what we talked about the last 2 days for the people that might have been out? Makes sense? All righty. So let's take this and let's go a little bit further with it. So looking at exercise 1 through, I can't use my finger on that one. So on exercise 1 through 3, it says we're going to write a translation map defined by each vector from the opening. Consider the vector v equal to -2, 5, and it is associated with a translation map of tvxy gives you x minus 2, y plus 5. Basically what this is stating is a fancy way of just stating, take any vector of x and y origin, and you're going to move it left 2 and up 5. So this is just describing the transformation of a vector. So if you start it there and I wanted you to do this, that's what you do. If I also say start at this vector and then go 5 units right, 7 units up, then I'll just say +5 +7 to tell the reader to take any of those and move it that direction. That's all this is a basically in math sense, what it's telling you to do, transform it in this form. So what we're going to do is we're going to use a few different examples. So this is going to be called vectors in component form. I got that question a lot yesterday on the homework. What is component form? Component form is basically it written out as a coordinate. So in this case, I'm going to give you 4 different ones, and we are going to produce a map for each one of them, right? So this is based on an example. So this will be U 3, -4. We'll have V -6, 0. We'll have W -2, 2, and T, which will be 5, 7. What I want to accomplish is I want to write these out as a transformation matrix. So again, this will be our transformation maps. Right? So just like this example, you would just say T for transformation, whatever the vector's name is. So in this case, U. It's in the form of XY. So I would just do parentheses, bracket, XY. It does get different when you are dealing with 3-dimensional. And then I'm going to write out this little matrix here. So this would be X plus 3, because that's what I would do if I wanted to use the U to move a different map somewhere. And then this would be Y -4. So any questions on how to write a transformation map? It's pretty much the same setup. The only thing that's going to change is whatever the vector's name is, and then whatever the actual vectors are that are moving. Is there any questions there? Yes, what do you got? Absorb it in. So basically, if I wanted you to take a vector in space and I wanted you to use the transformation U, then I can take whatever that vector in space is and add 3 from the X and subtract 4 from the Y, and I would have its new transformation according to the transformation of U. What I want you to do is do the next 3 real quick, just be able to write it out, and then we'll check it here in a second. So this is just notational parts. Make sure you understand how to write it and read it. You could just say Y. You wouldn't be wrong by saying +0 because that doesn't do anything. But you could simply just say Y as well. That would actually be the correct notation is to say Y. Alrighty, I don't see many pencils moving, so let's go over this. So again, T for transformation, V for the name of the vector. Funny joke. Okay. All right. So this will just be x minus 6, because again, I'll take whatever x value, move it 6. I would probably not count off if you did y plus 0, but it would just simply just be y, basically stating, just like earlier, when I wanted to move it 6 to the left, I wouldn't touch the y. The y would remain whatever it wanted to be. Right? And then continue with the process, tw, xy, you would get x minus 2, y plus 2. And the last one, tt, xy, x plus 5, x plus 7. Any questions on how to write it or read it? Yes. Yes. Did I not write? That's a 7. Oh, you're right. It's a y. Y plus 7 on the bottom. Good catch. Y plus 7. Any other catches I messed up on? Anything I need to clarify? All right, so now that we understand the notation, how to read the notation, let's actually move a two-dimensional object in space, and we're going to move it. We'll start off something simple. We'll move a circle. Let's look at number 2. So suppose we apply the transformation map TV. This is going to be the original thing on number 1, not the TV we just wrote in our chart. So this is the TV that's in the actual example number 1, where it says x minus 2, y plus 5. That's the TV we're going to look at. And it's on this circle equation. I don't know. In algebra 2, did y'all learn about circle equations? Did you graph circles? Let me start with that. So do you ever get to the conic section of algebra 2? We had circles, hyperbolas, parabolas, or ellipses? That's fine. Sorry. This is going to assume you already know that. A circle is written in the form of x minus h squared plus y minus k squared equals r squared. Where the center, this is a quick rundown in algebra 2, the center is h comma k, and the radius would be r. So that's basically how you write it. So if you know what the center of the circle is and you know what the radius is, you'll be able to instantly write this out as an equation. And then we could technically graph this in a calculator if I took out the, if I allowed the relations back on the calculators. But in reality, you can still solve it even without relations. When you solve for y, you would end up with a result of plus or minus a answer. You would just graph both portions and it would make half a circle and then graph the other half of the circle in space. So we can get away with that using our calculator as well, but that's not what we're focused on. Questions on how a circle equation is written. That part they assume you already know. Okay, so with that said, what is the radius and center of this original circle? So what's my radius here? 5. Why is it 5? Very good. The formula is r squared. So if you want to know what the radius is, you would take the square root of it. So if r squared is equal to 25, take the square root, I now get r is equal to 5. So my radius in this situation is 5. What would be the center? Pay attention to the sign. See how these both are minus? So you would change the sign of your center. So this 4 right here will become negative 4. And this negative 3 will become a positive 3. So that's the only tricky thing about the conic section, if you would have gotten to that point, is because the formula has a minus sign in it, you always want to take the opposite of their signs. Anytime they're in a parentheses, technically, you always want to take the opposite. So any questions then on finding radius or the center? So once you know how to read a circle equation, you should be able to quickly pull the information out. This is an ACT question, non-calculator portion where it just simply asks for the center and radius. That's all it asks you to do on the test. And it's expecting you to memorize what an equation for circle is. So if you see this, hopefully next time you'll be able to answer that question if you didn't already figure that out. Good? All right. Part B, show that the image point satisfies the equations of another circle. All right. Basically, what that means is if we use TV as our transformation, here's our original equation. X plus 4 squared plus y minus 3 squared equals 25. This is our original equation. This is what was on number 1 from above. It was TV x, y, x minus 2, x plus, y plus 5. So to move this circle and produce another equation, what we're going to do is we're going to replace x with x minus 2, and then go ahead. To produce the center. Yeah, this is just the original equation. We're going to go find a new equation with this transformation. So I'm going to replace x with x minus 2, and I'm going to replace y with y plus 5. I'll show you a more common sense way to do this, but I want you to have an understanding of how this is all done. So I'm going to replace x with x minus 2, and there's still a plus 4 there, squared. I'm going to replace y with y plus 5, but there was still a minus 3 there. So all I did to map this transformation on this circle is I just replaced x and y with whatever the transformation was. In this case, it was x minus 2 and y plus 5. So everyone good with this? Now I'm just going to simplify it. What is negative 2 plus 4? So I get x plus 2 squared. And what's 5 minus 3? So I get y plus 2 squared equals 25. Maybe we should have started with C so we could have graphed it. All right, I'm actually going to skip to C and we'll come back and fix B, but maybe a graph would make more sense here. So if we graph, what are the center, the radius of the image of the circle? Do y'all have a graph on y'all's? Y'all do? No? Do you have a graph? No, on part C. Okay, because let's quickly do a little drawing here. All right, if I just focus on the center, the 1, 2, 3, 4, and then I go up 1, 2, 3. Let's just take that point alone. If we want to transform that point, this means I need to go left 2, up 5. So this will be 1, 2, and then so roughly right here, that would be over 2, up 5. What would this new point be? It looks like 6a. So 1, 2, 3, 4, 5, 6, or negative 6. And 1, 2, 3, 4, 5, 6, 7, 8. Which is not the points that we got. All right, so with that said, let's go fix our mistakes. Sure. All right. No, so okay, so the way it works here is I got you. Basically, that's what you can just do and just move it. I think it might be easier just to move it and then know what your new points are and then just rewrite it. So like if I know that I'm taking that point and I'm moving it here, then I could just skip straight to my answer since I know what the circle equation is. But what they wanted you to do, and I'll show you here real quick, but I'm good either way, is that if x prime, my new points, are equal to x minus 2. And y prime, again, x prime and y prime just being the new center. We don't know what it is, but we do know whatever it is, I need it to be shifted 2 to the left and 5 up. They want you to solve for x and y to be able to plug into it. So here, I would get x prime plus 2, because I would subtract the 2 over. So that'd be x prime plus 2 equals x. Go ahead. I did. Yeah. And then same thing with this one as well. You would get y prime minus 5 equals y. This is what you want to replace your x and y with. So then you would get x prime, which is your new point, plus 2 plus 4. Y then will replace with y prime minus 5 minus 3 equals 25. So then I get x prime plus 6 squared and y prime minus 8 squared equals 25. So that's how they produce those equations. I think it's actually an easier way to take the center, whatever the center is, and then do the transformation, find the new center, and then just rewrite the equation with the new center. Because I feel like this part is a little bit extra in my opinion. But there's an algebraic approach and then a geometric approach. I find the geometric approach to be easier. Any questions? Yeah, so like right here. So what I would do is if I know that -4, 3 is my point, my center, and I know that the transformation's moving my x to the left, well, -4 minus 2 would give me -6. And then if I'm adding 5 to my y, that would give me 8. I found my new center. So my new center here is -6, 8. With that, I can just plug it into my circle equation and then instantly get my answer without having to worry about all of this. I find that to be the easiest way. Pending, you know what this is. Yeah. Because they won't give that equation to you. So you're going to have to kind of remember the setup. And then what was the radius of this circle? 5. The radius did not change. We just transformed or translated, I guess is the correct word, translated the circle left to up 5, but we didn't change the shape of the circle. So the radius itself would still be 5. Any questions there? So again, for this, I find the geometric approach to be the easier approach. So I took this circle here. Yeah. So let me show you my beautiful drawing of a circle. This is not big enough. In general, we took a circle with a center of -4, 3, and then I took that circle and I moved it left 2 up 5 to produce a new circle. That's basically what I just did. So basically, here's my original equation for my original circle. I use this transformation to move the circle to here. Now I have a new center. The radius obviously didn't change. Okay. I was going to graph it, but I obviously don't have enough space. Anyone know how to graph a circle? Just start off with your 4 points. If you know the radius, whatever the radius is, just go that many up, down, left, and right, and then pretend you make a perfect circle. Best approach. That's how I'll do it, at least. Try and make it not look like any ellipse. All right, let's look at another example. Look at exercise 3. Suppose we apply the same translation map TV to each point on a line. All right, so we have tx minus 3y equals 10. Question, or part A says, what are the slope and y-intercept of a original line? Real quick, algebra 1 question. What form is this in? I heard us. No, what's it currently in? It's in standard form. Very good. Remember, this is the form it needs to be in before you produce a matrix for system of equations. A lot of y'all, if y'all missed number one, that was the reason. So this is called standard form. I want to put it in what? Slope intercept so I can easily find my slope intercept. What is the slope intercept form real quick? Very good. The one thing we all remember, but a lot of times we just don't know what it means. All right, so simply just solve for x here. So I'm going to subtract 2x on both sides. I get negative 3y. I'm going to go ahead and kind of put it in that order. So it's negative 2x plus 10. If you write it as 10 minus 2x, you're not incorrect. It's just not in the right form. Why did I not combine those, though? Make it just 8x. Good. They're not like terms. There's not an x in the 10. So I cannot actually combine those. I leave them like it is. Right, Jacob? And then I'm going to divide both sides by negative 3. Two negatives make a positive. So I get 2/3 x. And then this is just going to keep it as negative 10/3. I think that comes out to 3.3 repeating, but we'll just leave it like that. So with that said, my slope is what? 2/3. My y-intercept is what? Good. So we'll say 0, negative 10/3. It didn't specify the right as a coordinate. It's just best practice. All right, part B now says show that the image point satisfies the equation of another line. So let's transform this. It was 2 on the left, 5 up, y plus, is that right? X minus 2, y plus 5, if I write it out. Okay, thank you. All right, this is the transformation I'm going to produce on it. All right, so I have my equation. You can use either one at this point, really and truly. I think I'm going to use this one here. I think it'll be a little bit easier. Again, my x prime and y prime will produce this answer. So if I go x prime equals x minus 2, to produce x, I'm just going to add the 2. So I now get x prime plus 2 equals x. And then y prime equals y plus 5. So to solve for y, I'm going to subtract 5. Go ahead. Well, I produced 2. I just solved for 1. I solved for both. So it's become this right here. What is it? It's a t v of this is going to equal this. So the transformation of any given point in space, so random point, they call it prime. So x prime, y prime, is going to have the form of the original point to the left 2 and the original point up 5. So then with that said, my original point would come from the equation x minus 2. So to solve for my original point, if I don't know what said original point is, I can just add 2. So now my original point will be 2 plus whatever the new point is. And the same concept here. New point will be old point minus 5. So to solve for old point, I can just add. Oh, wait, it was plus 5. I can subtract 5 from the new point. So we write it like this. So now I can plug it into this equation to solve for said new points. So you could geometrically approach this like we did with the circle. And I think that's on part C. So I'm going to write part C here for y'all. So I don't know if that's on the same page as y'all or not, but part C, it wants you to graph both of them. So if you graph the first one, 1, 2, 3, 4, roughly right here would be the y-intercept. And then you would go up 1, 2, then 1, 2, 3. Roughly This is your first line. Let's call it Y. To move this left to up 5, I can technically take any one of these points and actually shift them left to up 5. So with a different color, that's what I was saying with the circle. Sometimes maybe it's just easier to do geometric approach and then write the equation of that. I really don't know what the easiest way. It's either you're geometrically or you're algebraically thinking. Whichever way you work best, I think both approaches are just as fine. But if I take this y-intercept and I shift it left 2, and then I go 1, 2, 3, 4, 5. So right there, shift it to, that would roughly be this new point. I'm going to draw a dotted line for right now. But this would mean that this right here got shifted to, and then up, shifted to the left, and then up 5. That's what this point did. Now, if I know I'm just transforming the line, is the slope going to change? No. So I can take this point and I can just apply the slope again, or I can move this point, however you want to look at it. But I'm going to just move this point. So I'm going to go up 2. So I'm about right here. And then over, rise right. 1, 2. I don't know about, give or take right. Oh. Give or take about right here. So then I can produce, I don't know. Super hard to draw a line. So now you can see that I took this entire line and I shifted it left 2 and up 5. So that's the geometric approach. What we're doing here is the algebraic approach to produce the same equation, or to produce a new equation, sorry. The new equation should have the same slope, just a new y-intercept. So we can try to calculate what that y-intercept is, or we can use the algebra approach and we can plug it in to figure out what the y-intercept is in that sense. So what I mean by that is if I take this question here on part B here, I now know y is y prime minus 5. And then 2/3 times x prime plus 2 minus 10/3. So again, all I did was replace the x and the y. Now, if you don't like fractions, you could technically plug it into this one as well and deal with your fractions at the end. So I replaced the x and the y with x and y from the formula using the algebra approach. Yes, sir. Here, here, here. This right, it's a 5. And then we can just work it out. So I work it out. So I get y prime minus 5 equals 2/3 x prime. 2/3 times 2. 4/3. Very good. Minus 10/3. Remember, we just multiplied the numerator. 4/3 minus 10/3. Good. It'd be negative 6/3, which ends up being just -2. Add the 5 with its like terms. So y prime would now be 2/3 x prime plus 3. And if I was a really good drawer, which I'm not saying I am, where did it go through on the y-intercept? At 3. That's just, I'm gonna take some, that's nice drawing on a little line there. But at least I was around the ballpark of 3. I know I'm in the right answer. So now I have my new translated equation. So you can either, again, use the algebra to solve it, or I could have just taken these 2 new points and then try to produce the equation that way. If this part here, if you're, again, not really great with fractions, you could technically plug it into here, and then you would deal with the fractions at the very end, just like you did when we solved it at this point. We dealt with a fraction at the very end. Multiple ways to do that approach. Go ahead. Yes, ma'am. Any questions? So we've now just transferred regular vectors. We translated circles. We've translated lines to produce new equations. Any questions? There could be. Yes. I won't give you the circles on the test, but it is an open note test. So make sure you highlight that circle equation if you need to find it. Not to my knowledge. Right now, it's just circles and lines. We're about to start talking about spheres here in a second, though. So we're about to get in three-dimensional shapes. So any questions on two-dimensional shapes? No. Same process. It's just there's a z-axis, but same process. Ready? Okay. Here we go. And we did see up there. One big thing again to notice, did the slope change? No. If you're just translating a line, it should have the same slope, just a new y-intercept. Correct. All right, so when we look at example 1 here, we're going to talk about vectors and translation maps in three-dimensional space. That's what R3 means. So we're going to translate this vector 1, 3, 5 by applying the transformation map. So I'm going to move my x by 1, my y by 3, and my z by 5. And here is your original new point of 2, -2, and 4. Right? Do y'all have that image on y'all's paper? Perfect. So if I take this image right here, 2, -2, 4, and I apply this, let's see where it lands. How do you think I would apply it? Just add them, that's right. So if I want my new points, so we'll call it A prime in this case. That's going to be this point right here. Yeah, it's just a point where it's not a vector. This is the vector. So we're going to take this point and then move it. So there's the translate. So the vector is our translation. So what I'm doing is I'm taking this point and I'm going to apply the translation to it and see where it lands. That's pretty much all we're doing. We're going to move a point in a three-dimensional space using a three-dimensional vector. So we should produce another point. So one thing when we're dealing with translations, the shape that we start with should never change. We started with a circle, we left with a circle. We started with a line, we left with the line. We're starting with a point, we should end with a point. So the shape of the object should not change. We're just moving the object in space. So in this case, this will just be 2 plus 1, -2 plus 3, 4 plus 5. And now I'll have my new point. So my A prime would equal what? Awesome. So 319. I don't know if I have a better shot here or there. I don't like how they don't label it. I don't know which one's which. I feel like this wasn't this like the X and this is the Z and this is the Y? I don't either. Yeah. I'm not going to try to graph it. We just need the new point. Actually, at this, to show you the graph, I can kind of sketch it here. If this is what my vector is in this direction, I'm basically taking this, and that's where my new point is. I don't know where that actually is. I assume that's going to be around 319, but I'm taking that point and I'm taking that vector and I'm moving it that length of that vector. That makes sense geometrically? You're just moving the object, whatever the length of the vector is. All right, let's look at one a little bit more complicated than that. So that was a point in space, in a three-dimensional space. Let's move a plane. Let's move a two-dimensional space, a two-dimensional object in three-dimensional space by this vector. All right. So you're given the plane 2x plus 3y minus z. All right. So this goes back to what we just saw in two-dimensional space. The mapping of this is t, was it a v they used? Okay. T v of x, y, z. Technically, these are the new points. So this is x prime, y prime, z prime. Will equal x plus 1, y plus 3, and z plus 5. So that's why I was making sure y'all understood the algebra part in a two-dimensional space. We're going to apply the same thing. We're going to produce three equations. X prime is equal to x plus 1. How would you solve for x? Perfect. So that'd be x prime minus 1 equals x. Step 2. Take y prime equals y plus 3. How would I solve for y? Subtract 3. So y prime minus 3 equals y. Step 3. Find z prime equal to z plus 5. That's a 5 up there, if you didn't know. I just copied it from the original example. How would I solve for z? Subtract 5. So z prime minus 5 equals z. Questions on this one-step equations? Once you have your x, y, and z, this is where the algebra part comes in. I'm just going to replace x, y, and z with the equations I just produced. So I now get something like this. Let's change color so you can see the next step. So in step 4, I'm going to plug in. So this now becomes 2 times x prime minus 1 plus 3 times y prime minus 3 minus my z, which is z prime minus 5 equals 0. Before I try to simplify this, questions? Make sense? All right. Now just apply math. How do I get rid of all these parentheses? Distribute. Do. All right, so we get 2x minus 2, or sorry, 2x prime minus 2 plus 3y prime minus 9, negative z prime plus 5. Biggest mistake, students always forget that minus. Make sure you apply it as if it was a negative. Combine like terms. We get 2x prime plus 3y prime minus z prime. What's that? Negative 2, negative 11, negative 6. We good with this so far? To clean this up into a better equation, all they do is move the 6 over. So your final answer would be 2x prime plus 3y prime minus z prime equals 6. I combine like terms. Negative 2 minus 9 is negative 11. Negative 11 plus 5 gives me negative 6. And I'm not going to even try to pretend to draw this out. But basically what just happened is I have a plane in space, and then I have a vector, and I basically took this plane and I moved it. So I end up with a new plane in space, depending on what the vector did. I guess it kind of went up like, I don't know, something like that. That makes sense? All I'm doing is moving it. Yeah. All right, so that's think that was, we got one more sphere. That was the last one. All right, so I will finish the rest of this tomorrow. Don't forget about your homework from lesson 15 and 17. Retakes on Thursday. Make sure you're studying for that. I have gone over all of that already.